Heben Flurban Urban Murin.
Hello, chat. Hi. Hi, everyone. I feel like it's been a million years. It sort of has. It sort of has been a million years. It's been a long time. I think it's been like over a full week. I hope everyone can see stuff okay, because I'm trying some new stuff with like the new Stream Elements plugins for OBS. It's got like some new multi-stream things and yada yada, all sorts of fancy widgets. Hi Ash, hi Prue. How are you? How is everyone? I'm glad I still have people who are willing to come watch me, even though I'm basically just here to fucking have a crash out live on stream. Holy freak! I hope everyone's having a good week. I hope so far. I was going to say hope so far everyone's like new 2025 January is going well, and then it started to really hit me that we're already most of the way done with January. We're frickin' where did the new year go? I don't know. We now have a frickin' new president in office. But we make do, right? We're just the dog in the fire in the LA wildfires. This is fine. Hi, Mr. E. Okay, I'm checking that all my new freaking Stream Element stuff are working. Now I finally, I don't know if I can incorporate it on my stream yet, but I now have all my chats consolidated into one chat box. So that's cool. Stream Elements has now got that like built in, so I don't have to worry about looking at a bunch of different chat boxes. And I think there's an option to multi-stream to do the like the vertical stream that goes in the YouTube shorts. Background music loud. Let's see. Is it still loud? Can you be on stream now? Does it show on the over? Let me see. Do. No, so even though it's okay, I still have to add a second source if I want to add YouTube chat, but I wonder if it's easy to do now. Let's see if I can do it right now. Stream elements chat box. Do. Wait, was it so loud you couldn't even hear me before? Yeah, you did manifest it. Just like at all the other times when you're thinking about me late at night, and then I show up. Stream elements. YouTube. Chat overlay. You love stream scuff? Well, get ready for more, because that's all. If there's anything I manifest, it's scuff. Scuff and girl fail. And this one. I've been feeling like sort of congesty, sniffly, coldy recently, and I don't know if it's just like allergies or if I've actually got something. And I sort of want to just not go into work for a couple days, even though I just had like a relatively long break. I sort of don't want to go into work but all the stuff I'm working on.
You got these nuts.
I will find you, and I will make sure you are never heard from again. I will make sure you are never heard from again. You're in my walls? Stream. You're goblin these nuts? But if you're a goblin, I'm ogreing, trolling, dragon, dragon. But honestly, what was I saying? I don't want to go into work because I feel sort of sicky, and I have like a freaking metric mountain load of homework due tomorrow. I've been frying my brain all day today while at work, balancing simultaneously doing work and slipping in like working on my homework in between doing work. In the office in my cubicle. You want a MATLAB tutorial stream today? I'm actually so down to do MATLAB because I actually need to do some MATLAB for my homework. But if we want to do that, I think I have to get it set up on my streaming account on my computer, because I don't have MATLAB on my streaming account on my computer. But I actually think it'd be pretty cool to make some MATLAB stuff. And a lot of the work the homework I'm doing uses MATLAB. Supposedly. Frickin' my goddamn professor had the nerve to he was teaching us all this theory about control systems. It's a control systems class. It's about linear optimal controls. And he's like, yeah, I'm teaching you this theory about all these matrices. And he spent like 45, 50 minutes talking about this theory for what are called linear quadratic regulators. And he's like, oh yeah, so it's like there's all these conversions where you're doing calculus and then, you know, use this identity and you can turn it into algebra, and you've got these big matrices. And then afterwards, and he's like, oh yeah, but really, you know, when you need this done, all you do is you type it in, and it's one line in MATLAB. And MATLAB does it all for you. And I was like, what the frick? What the frick? But he was talking about how it's still important to know, like, the theory behind it, because sometimes MATLAB pops errors, and then you need to know, like, what you did wrong. Do you have a probability class that requires a ton of MATLAB coding? Okay, so I mean, I feel like that would probably be pretty... I don't want to say easy, but I can see how it would be, like, right along the lines of straightforward to teach and to use MATLAB, and it'd be a great, like, introduction to, like, using MATLAB to simulate lots of things, because it's just a procedural that, like, loops a million times and adds to different counters, is what I'm imagining, right? They probably have, your, like, opening assignments are probably to do, like, what's it called? Monty Hall problem simulation? Monte Carlo, was it? Yeah, Monte Carlo simulations? Where more or less it just, like, does the thing, like, a million times. Do, 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 do. 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 Rich. I'm trying to figure out the settings to enable the YouTube chat box for my overlay. Oh, you used R. I only started using, I had to use R2. That was a year ago? 6 months ago? R is like a really interesting statistical one, because that's like all about like actually generating like curves for and data sets and stuff like that. It's been freaking... I honestly never used R ever in undergrad. I like when they asked me, they brought up R, and I think there was some added library. You need your body to generate some curves. I'll generate some curves on your body. You'll be curvier after I'm done with you. Not really. Not really. I don't know that. Don't ask me the details of how that would physically work. Chat box. How do I do? Link Streamlabs to YouTube. Do. Sorry, bear with me as I puzzle this out. You generate curve by lifting weights? I generate curves by lifting your mom. Got him. Got him. My YouTube is connected. Why does it not show my... I'm so confused why it doesn't show my YouTube channel. Do I use Streamlabs OBS? No, I use normal OBS. But the chat box is just an overlay. It's a HTML, not HTML. It's just a like URL, basically. You generate curved black holes by Joke's on you, physically impossible. Lifting my mom is physically impossible. Nope, didn't show up. Freak! Oh, it's linked to the wrong YouTube. Frick. Let me fix this. I think. Bam. What the frick? Why is this so difficult? Brr. Chat's a pain in the butt? Why do you say that, Mystery? Do you have problems with chat, too? Frick. Frick! OBS should have a chat source you can add without having to do any coding. Chat and working go together like... Yeah, I agree. I agree, Hassel. I just don't... So what happened is, I apparently have the wrong YouTube account linked with my Streamlabs, right? Which it seems like, okay, just unlink it. But it's like apparently listed as the primary account linked with my Streamlabs, so my Streamlabs, like, I can't unlink it for some reason, or I'm not seeing a way to unlink it. Freak. Freak. YouTube guide?
Today I'm gonna go ahead and show you how you can unlink your
Friggity frick. How did this happen? I was gonna talk about crazy frickin' math today, and now we're stuck dealing with me not being, basically being, like, technically illiterate. Technically illiterate. Unable to operate basic technology. Hi, Basic. I'm Dad. Yes, it has been that way for a freaking... Honestly, I wonder, like, do people consider me like an old freaking... boomer person. Me and some of my coworkers were laughing today, right? Because one of them got an email from one of the older coworkers, and it was one of those emails where there's nothing in the message of the email. It's only they put the entire message in the subject line, and it was like, "I'm back from break. Did you miss me? LOL," in parentheses. And the U was just the letter U. And so we were all like laughing in chat, like, "Oh man, the boomers are back." And then one of my other coworkers, she was like, "Guys, I would say this." And I was like, "Oh my god, we're old. Oh my god, we're old." We're at a point where people are going to be performing boomer actions. Frick. Can't believe it. "22. Definitely, definitely not 27. Definitely not old and 27. Feels like it's been longer, Penboo? What does that mean? What does that mean? I can't, like, is that a good thing or a bad thing, right? If you like, have been married to someone, or you have some form of relationship with someone, right? And you're like, "Oh, we've only known each other for, 5 years." It feels like it's been an eternity, right? Like, is that a bad thing? I feel like I've been stuck with you forever. Okay. If I keep messing with this thing, I'm honestly going to crash out. So we're giving up on it for now. I think what I have to do is I have to nuke it, destroy this Streamlabs account that's linked with the wrong YouTube account, and create a brand new Streamlabs account. A brand spanking new Streamlabs account based off my Twitch account, and then link it with the right YouTube account. You think it's possibly? I mean, I don't know, guys. I sort of see where you're coming from, because a lot of the VTubers I watch, I'm like, holy cow, Halloween is like 5 years now or some shit like that. I've been watching these VTubers for years. I've spent more time with some of these VTubers than I spent in undergrad. I wasn't even like an OG VTuber enjoyer. I mean, I guess it depends where like, I was definitely on that like big explosion bandwagon. And when you guys first discovered VTubers, did you think they were like sort of cringe? Sort of cringe? Because I'll be honest, when I first was like on YouTube and I was just seeing like in the like recommended feed before I watched VTubers, when I saw, occasional images of Gargura, I was like, huh? Isn't that sort of cringe? And here we are. I've become the cringe source myself. I laugh, but it's only to hide the pain inside. You never thought to compare. I mean, that's what cause that's the metric of like, what have I experienced for 5 years of my, like, that it's more time, 5 years is more time than I spent in college. I guess you could compare it to high school, but high school feels so far back now. You saw VTubers so long. I mean, I don't know, guys. I don't know. What did I want to do today? You guys want to see the freaking part of the source of my crashing out? I'm glad you're happy to have started. I'm so... Guys, you have... honestly, I don't know why anyone watches me. Part of me is like, oh, they just watch me because I have a really cute model. Because I do. It's the cutest. But also, like, I don't feel like I contribute much to... to anyone's day. Launch an OnlyFans live on stream? All I'm gonna say is maybe it's already out there. And I just don't affiliate it with, you know? You know, maybe it's... Or you'll have to scour the web, or you'll never know. You'll never know. You're here for the milling machine? Bear. Bear. Hey, can I still do this? Oh, that's not what I wanted. Okay. Bear. Bear. Chat. I just want to freaking briefly... Wait a second. Wait a second. I never fucking knew this. You guys see the white, like, border around my model here. Right? I did not know that on this view... it doesn't show up because it's behind the layer that my Krita's on? Question mark? Wait, no. Oh. Okay, never mind. It's just I don't even have it on this source screen thingy OBS thingamajig. I saw that too. I saw there was someone who uploaded a video on, like, it was some level of math. It was like straight math. It was like differential equations or something like that. And she uploaded the same exact video to YouTube and the hub. And she made more money on the hub, and all the comments were not what I expected to see here, but interesting watch nonetheless. This isn't what I was looking for, but I watched it all the way through. Just anyway. Girl boss indeed. Girl boss indeed. Hey chat. Have you got... I want to know. Do you guys know, like, about, like, all the weird shit about E? Like, the like, number E? And you've got, like, the weird shit where, like, e to the x is, like, an exponential function, right? And that's, like, that plot's like this. Really important. And then you've got, like, weird shit where it's, like, e to the I turns into, like, something sine, something I cosine, or something like that. Freaking... You guys have seen all the weird shit with E, right? I'm gonna fucking fry your fucking brains, okay? Oh, it's... the I goes with the sign. You're right. You're right. You're right. This is why people don't pay me to do math, because I can't remember this bullshit. E to the I gives... Yeah, e to the ix gives cosine x plus I sine x. This paintbrush is fat. I forgot. It's been way too long.
Fry my brain harder, mommy.
I'm gonna fucking... You got... Now, okay, so clearly Hessel fucking knows his way around E. Have you ever seen this bullshit? Have you ever seen E, and then it's to the power of something, right? E to... We'll say T, because that's what I normally... Except, this isn't a number. A is not a number. A is a fucking matrix, so it could be like 1, 2, 3, 4. Did you know that's a thing? Do you know this? This is like the biggest bullshit I've ever learned. I learned this last year. This is like... Yeah, and it's like actually useful, right? It's like actually useful. Freaking... So it's based off this whole, like, there's an identity for e to the x, or e to the whatever, e to the t, right? Is equal to 1 plus, like, 1 over 1 e squared plus 1 over 2, what's it, factorial? Factorial? Wait, it's not squared here, it's the first power. T squared plus 1 over 3 factorial t. Okay? This freaking bullshit, right? Like, this makes sense with numbers, and then you find out that because of this, like, identity, and because if you have a square matrix, it has to be square. It has to be square, like your mom. Not really. Your mom's pretty round. Because you can have... How do I guess we will use numbers. 3, 4. You can do a squared. It's literally just that matrix times itself. One, two, three, four, and so on, right? You can actually do this identity with matrices. Have I heard of the wedge product? No. And I'm not, if this is crazy math, I'm not sure I want to know, because every time I learn more math, I'm like, dude, what the fuck? But, the weirder thing to me is, like, so much of the math I learned in university, I, like, don't feel like is ever useful. All of linear algebra, I was like, when will I ever use this? And I think I used linear algebra for my upper div classes once, when it was like a MATLAB class on, like, finite element analysis. But now, in grad school, learning about control systems, I find out that this shit is actually useful for the first time, and it's because of, like, weird stuff going on with this. Because if you have a normal differential equation, right? Nope, that shouldn't be done, right? This is an ordinary differential equation for, I think it's first order? Whatever. This, you see, and it's like, oh, this works on normal numbers. But now, because you understand that you can apply this to matrices, you can do this with vectors now. I think hat is how a lot of people do vectors, and then you do it with vectors. And that, like, again, this seems like, what the fuck's the use of this? But if you start, like, looking at actual physical things, you have, like, 3 blocks held together by springs, right? When you describe a system of, like, spring masses, what you need to know, like, their displacement from origin, right? That's one of the factors, because that's, like, the multiplier for the spring constant, because the force is times kx, and you need to know their velocity, because that, you know, indicates the state of the system. But when you have, like, this 3 spring mass system, you can turn it into a goddamn big ass vector, where the first thing is, like, position of block 1, then the second thing is velocity of block 1, whoops, and then you do that for the second block, and then the third block, and then on the other side you have that same thing, like, dotted, right? So this is your x vector, and this is your x dot vector, right? This is your x, and this is your x dot. And then here you can make your matrix based off of, like, the fundamental physical equations. And you can actually just do the equations for all 3 of these blocks of motions all in one. And it just turns into, like, one singular equation, where before you had, like, 6. And they were all, like, weirdly interlinked. And, like, it sounds so, like, weirdly overcomplicated. But it's so interesting when you actually learn about it, because then you can do stuff like, if you know that they're all initially displaced, like, different amounts, like this is displaced 5, and it's given an initial velocity of, like, -1, right? And this is, you know, 3, and this is 0, but this has, like, +1 velocity, right? You just plug them into one singular equation, and it tells you the entire motion for all of them. And, like, this is really, like, scary looking, because realistically, this one equation is, like, a 6x6 matrix. But that doesn't matter, because, you know, 6x6 matrices are nothing to MATLAB. You know, you go to MATLAB and you're like, hey, here's a 6x6 square, and you just fucking generate everything you need to know off this one bit of bullshit, where you've turned, like, this normal looking equation into God's monstrosity of 6x6 matrices. Yes, exactly. So x dot here, it would be p1 dot, b1 dot, and so forth. Except, so here's, like, the interesting thing, right? Because v1 is already the time derivative of p1, right? This whole, like, line is just, like, or this whole line, right? The p1 dot is just equal to this. Wait, 1, 2, 3, 4, this. Because all it is you just basically select this one unit from the vector. Turns into p1 dot. So if we wanted to do this exact system, right, where this is 1, 2, 3, and we'll go with that same notation where our x vector, right? X vector is P1, B1, P2, B2, B3, B3. And then the other side is the time derivatives. P1 dot P1 dot P2 dot B2 dot B3 dot B3 dot. Like, I can actually do up this matrix relatively quickly, because this one is just this, right? Where all we're doing is we're pulling the velocity from the vector that we already have. This second one is the exact same sort of idea. This last one is the exact same sort of idea. We've already done half our lines, right? This is one line. Whoops, I did it on the wrong line. 0, 0, 0, 0, 0, 1. This is one line. This is 2 lines. This is 3 lines. The remaining 3 lines are really easy because all you do is you look at this block, which the only force on it is the force from the spring, which is equal to K, and that's the spring constant times like how compressed it is, which is based on how far these blocks have moved, right? So it's P2 minus P1. So that just means for here it's P2, which is our third unit, minus P1. And then this one is the same, like, I don't want to do the middle one because that has to do with all 3 of them, but the third one is P3 P2 minus P3. Great. And blah 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 blah. Right? I guess I can do this one. I think it's -2, 1, 1. I would have to draw out more, like, smaller free body diagrams to check it. But, like, now, having done, like, just that simple, like, it's just a block of numbers and you just sort of look at it and you're like, oh, this is a 1, this is a 0, this is a, you know? And now, I plug this into MATLAB, right, using this equation, and it gives me the time-based function for all of them. It tells me at what point all of them will be where. Sorry, this has been like a huge ramble, and not at all, like, I understand that what I'm saying is not, like, clear at all. But I'm not really trying to teach you as much as I'm rambling about how education, I almost feel like education has failed me because I went to school for, like, in undergrad and learned all this linear algebra shit, and I was like, what the fuck is the point of this? This is completely useless. Went frickin' 4 more years, wait, no. This was like 2nd year undergrad, 1st year undergrad, 6 years? Something like that. It'd been like 5 or 6 years since I used this, and only now in grad school are they like, yeah, this is actually meaningful to something you might see. Like, this is actually, like, you can actually use this for, like, something in the real world. Freaking This is the problem with math classes. You're like, what the fuck's the point of this? This is how meth is made? Yes. Yes. And I am honestly ready to become an addict, because that's what I'm gonna need if people are gonna keep telling me, oh yeah, that stuff that you learned and thought you would never use is actually useful, but I'm not gonna tell you how to use it until like 10 years after. Next, someone's gonna come up to me and be like, yeah, remember titrations in chem lab? Where you had to just very, very slowly, you're adding like a single drop, a single minute little tiny little drop to turn the color of the thing purple. Remember that? That's actually useful. I don't know. Sorry, I'm just here rambling about random bullshit right now, because I honestly just want to complain about how freaking and it fried my brain, like, learning all this too. It fried, you like see this and you're like, huh? It just ends up being like your differential equation professor showing us a 1 volt 1 amp RLC circuit to calculate bleh. You know, I still, my engineering classes are talk about Laplace. Wait. Laplace transform is the one that goes into S domain, right? Am I at frequency domain? Or is it, or am I mistaken? Anyway, they still talk about that, and I still don't understand, like, how that gets applied. Literal example of exactly what I'm talking about, where I still, like, what the frick is the point of this, like, S domain? Besides, I mean, I sort of get it. It makes calculations easier, right? But freaking, it's not, like, intuitive at all. It's not. Just read the mystery. You think the things that, like, they're having us work with now have a chart? We don't have a chart. We have, they gave us an equation. They're like, oh yeah, with this matrix, when you need, you know, transfer functions, you can generate it from this matrix. When you guys learned it, did you learn it with matrices either? I don't know if I remember it being with matrices either. Freaking, basically, I'm coming to realize now that all the, like, matrix and vector stuff that, like, never got applied realistically that much to me in undergrad, like, all the, like, you can use that for all the math now. But, like, it's sort of cool, right? Because you now get to see, like, shit. You get to see like how things are actually useful. I learned, like, about how this exact stuff with you know, the matrix functions and generating these functions, you can apply it to satellites. You can apply it to, like, the motion of satellite, and there's these other cool concepts of, like, you know, if you have a satellite orbiting Earth, how many thrusters do you need to make sure it stays in the right orbit? Do you need 2? Do you only need 1? Do you need 6 for like different axes? Hi, cat goes mew. Hi, cat goes mew. Yeah. Mew. Mew. 6 sounds like a good number, Mystery, but that's exactly what I'm talking about. We have to bring back Krita. We have to bring back, I was for this class that I was talking about with all the matrices, it was literally like the same sort of problem, right? With some matrix. And it was 4x4. And the state vector, right, the x that I was talking about, was based off of a satellite orbiting the Earth. Right? Going around the Earth. And it was like, this was like distance from Earth, I guess we'll go with the radially. This was like velocity in that direction. And then there was like distance from nominal radially, like there get compared to some nominal orbit. And then the velocity for that, right? And it was literally about like how if you have a satellite orbiting the Earth, right? And there's some nominal orbit path. And for some reason something happens and your satellite like gets displaced. It goes off the nominal orbit path. What does it take to control it? And there's this whole theory of controls about like, it's called controllability and observability. It's like, how much does it take to be able to fully move it? And apparently, all you need is one singular thruster for this model, where like, if you depart this orbit for some reason and you end up like, instead of nominally was here, you somehow ended up like here, right? So you've departed it tangentially and like radially. All you actually need is you only need a singular thruster. A singular thruster that I think it was one that was radial. And if you have the singular radial thruster, you can actually put yourself back onto the nominal orbit. Do I sound like a crackhead? I feel like that one meme of the guy from It's Always Sunny in Philadelphia, where he's got like the map and the string up poster, and he's like, I mean, it's total crackhead. Hassel, I will strangle you with all the power of the state. That's the state that I'm talking about. You're going to state prison. State prison. Do they use spinny things to steer too? Are you Turkey? Are you talking about like the Kerbal Space Program, like spinny control wheels? Obviously that wasn't like... I actually don't even know. I'm sure that this model that like was in my final exam, I'm sure it was not like super completely perfectly accurate, because of course there's only freaking four components to the state variable, right? And I'm sure, you know, when NASA does these things, I'm sure their calculations are much bigger, and it wouldn't surprise me if they use completely different math, because this only works on like linear systems, right? This is linear algebra. Linear. If you have something that's not linear, then you can't use this. But my understanding is like, if you have something not linear, you just use linear approximations, and then you can use this. Did I just reverb you guys while I coughed? Instead of muting myself? I meant to mute myself while coughing, and I think I probably just reverbed you while coughing. Yup, wrong button. Spin a disc to turn satellites? Cough ASMR? Okay guys, chat, how many of you guys like ASMR? Like, I honestly feel like ASMR is like a niche thing, but it seems like so many VTubers do it that it can't be that niche. Or maybe it's like there's a really big middle ground on the Venn diagram between VTuber enjoyers and ASMR enjoyers. Some of them do gyroscopes. That sounds reasonable. I don't know for sure. I actually have a friend who works on satellites though, that we used to play games, but he did a lot of work for Millennium Space Systems, and he's now like a chief engineer working at a university that does a bunch of space programs for their the university gets contracted by the government to put satellites in space. So I would have to ask him, but he said there's a lot to it. Of course there's a lot to it. I remember he was talking to me about like space dust and all sorts of other stuff and how different ways that they control them. But I also feel like I'm pretty sure you can't do all the controls for orbit with wheels, because wheels don't change momentum of the system, right? Wheels will just allow you to turn it, right? Maybe that's wrong. I don't know. I feel like if you want to like change, velocity of the center of mass, right? That's what you have to do to like change where something's actually going. What you need some sort of mass transfer from a thruster. So I feel like they all at least need one sort of mass transfer device. Twitch knows when you're not looking at the tab and artificially extends the ad break. Maybe. Joke's on you, I wouldn't know because I used the Twitch Turbo thingamabobber. If you had one thruster and could turn in any direction, you'd be good to go? Probably. I mean, I'm considering that you don't even, like with the model I was literally just talking about, there was no need to turn. It was literally just one thruster. You could put yourself back on the right orbit. I'm sure that's true. I'm sure being able to turn only increases your options. Frick. I should go back and because I have the exact problem that I'm talking about. I have it in my notes somewhere. Maybe I should go back and we can review it together, and I can tell you all about like the weird mysteries of controllability and observability, and how technically they say some wild shit because they're like, yeah, technically controllability is time invariant. That's like a word, the time invariant. It means time doesn't matter. If it's controllable to some point at 10 seconds, you can control it to that point at 0.1 second, right? Anything that you could do in 10 seconds, you can do in 0.1 second, technically, if you wanted to. You would just need an immeasurable amount of volatile force. You need huge violence. You would need a thruster that was literally like the size of 10 space shuttle thrusters strapped together. But if you had enough force, you could do it. That was an interesting conversation to have with my professor. I was like, oh, so you mean to tell me I could do anything at infinite speed? And he's like, well, that's exactly what I'm telling you. So basically you can't? Kind of. So there's this other thing for like, what I was talking about is like controllability, right? This is like literally something that I was talking about in my like optimization class, where if you have some system, right? and say you have object here and you want it here, right? Part of optimization is like understanding like how you want to define your optimization, because of course if you want it there, you sort of want it there like fast. But if you wanted it there immediately, you'd have to hit it with like a mega sledgehammer. So you have to like weigh this idea of like, we'll call it T for how fast you can get it to converge on your target point, and we'll call it U for how much effort you want to put in, right? You have to balance, like, you can have a system where you converge to where you want to be, like, really quickly, right? You go straight to your target really quickly. I shouldn't have said T, I should have said, like, D or something. But basically, you get there really quickly, but in exchange, the force you have to put in has to be, like, really large. Oops. Really large. Or, your other option is you can accept that it's going to converge, like, slower, and it's gonna look like new, right? And it's gonna converge slower, but in exchange, you need less effort, right? And so that's like this whole thing that I'm supposedly studying right now. It's like this optimization of balances. But no, Mr. E, you say crazy impractical thing, but it's not crazy impractical, because like all you have to do is you have to like, you do this analysis between these two, and all you do is you look at what physically, what happened to my music? What happened to my music? I need to make sure that I don't end up playing something copyrighted. Right, you do this analysis. Sorry, I'm back. You do this analysis, and all you do is like, if your thruster has some limit, like it can only put out 1,000 newtons, right? Obviously, anything that goes over that 1,000 newton line doesn't work. So all you do is you do this balance and you trim it to the exact point where your controller uses just barely below. That's the whole name of the game. You do this analysis to compare like how one affects the other, and you trim it to just barely below the limit. And that's how you like optimize, right? So it's not like super like, oh, you know, we're talking about, you know, going light speed. It's truly never a useful thing to think about, because you just you do this logic, and then all you do is you reel it back just the right amount, and then you end up with crazy feats of engineering where you have like the Blackbird, the God's gift to mankind in speed. Could this be used for controlling it? Yes. Yeah, that's like, those are like the exact applications that you can use this for. Physical motion, things like that. Electrical stuff, you could use this for like maximizing the speed that you can get your system running, right? Bringing up all your voltages to the right voltages for your FPGAs, or you're charging different, you know, capacitors or whatever. Like, this is how you like really optimize performance for different things. I'm sure there's tons of this stuff going on at like tech startups for electrical engineers, for, you know, graphics cards or processors. I'm sure you've got like stuff like this going on there. And of course, of course it's going on in aerospace. Really, like, any system where you have, like, these input-output control systems, someone's going to want to go as fast as possible. So they need to do this sort of analysis. Although, I'm not gonna lie, like, unless you're going to make your career out of doing this analysis for that, specific industry, my suspicion is the people who do this for the career in that industry probably do it better than you will. Like, I, of course, am not going to be able to develop a speed controller for my car that does better than, the people developing speed controllers at Tesla. Or even probably, Toyota or Ford or whatever, right? Because if you do this for a living, you're going to do it better than I'm gonna do it. So it's sort of like, to me, it's sort of not even worth thinking about for most of the things that I do. But if I want to work on, if I, not to dox myself, if I work on, 747s, maybe there's some use for me to make my living working on the control systems for them. Who knows? Who knows? I mean, it's a cool project to do yourself. It's for sure. And like, if you wanna, you're just like a tinker, right? Like, I am sure if you just build stuff like Michael Reeves or like Stuff Made Here. Frick, I forgot there's a Stuff Made Here video. You guys wanna watch it? I haven't seen it yet. But if you just build stuff like that, right? And you wanna like really push the limits. You wanna make your homemade robot go as fast as possible. Like, it's really interesting that you can see how all this stuff actually goes into tuning. Not that I'm explaining it to you in a level that you can actually do. Frick. I can't explain it yet because I don't even know if I can finish this homework yet. Let's see. Sorry for yapping, guys. I'm just here yapping about like the weirdest, most random, dumb math engineering stuff. You want to build? Okay, I mean, so the question is, Mystery, are you just saying put together a car, or you want to like design a car? Because imagine how much work it is to design an engine, even just the engine. I feel like that must be a lifetime's worth of work for one person. So you're going to use an engine that already exists. The question is, what are you going to get COTS, right? What are you gonna get consumer off the shelf and just take someone else's? And what are you going to design yourself? Not that it matters. I mean, even if all you're doing is building a car like the same stock car from like Toyota or whatever, even if all you're doing is you're copying them, it's still cool, right? But it's just, I wonder how much effort it takes to like, if a singular person had to like completely engineer a car, do you think they even could do it in their lifetime? Like a modern level car? The old ones probably, right? Stuff made here. Do.
Got a question.
You guys want to watch the stuff made here video with me? I've been I saw this. He posted this like a month ago, and I saw it almost immediately, but I didn't watch it because I was like, this is something I should watch on stream. I hope YouTube doesn't do that YouTube detection thing and kill my YouTube stream, because I realized that was something that was happening. Good night, Hassel. Good night. Let me make sure all my stuff is in order.
Question for you. If
Oh.
cameras are so good at seeing stuff, why can't they see around stuff?
How's
You
the
might think
audio?
it's impossible for the camera to see me back here, but it's not. With the right kind of camera, in theory, you should be able to see around walls. And to prove it, I built one.
It's a very weird camera. It can only see 1 pixel, but it can make full images. And it can do a lot more than see around things.
We can make it behave like any lens, including crazy lenses that would be almost impossible to make. And I know I say it every time, but this thing was so painful to get working. If anything is off at all, you just get crazy images out of this, and a lot of stuff was off. I also hope we can get some nice portraits of my wife's face. I'm really interested in what her face would look like if we could see around it. I'm not sure if that's going to be flattering or not, so no promises. So let's
This
get
is
into
like
it.
a really crazy idea.
I think everything will make a lot more sense if we first talk about how normal cameras work. So imagine that I have a box, and inside my box, we have a little ant, and then outside the box, there's stuff. And then imagine we poke a little hole in our box. And if our little ant looked out of the hole, it would just see some little tiny part of what's out there. And if our ant walked down the box to a different spot and looked out, it would see some other little tiny part. If you think about it, the ant walking from one side to the other, it would see every point that's out there. And this is how cameras work. Instead of an ant, there's some kind of sensor or film, and whatever's out here, if there's light on it, the light bouncing off it will go in and hit this sensor at different points.
And the sensor measures at every point on it how bright the light is that's hitting it. And this is all a photograph is. A bunch of points that are light or dark, depending on how bright the light was that hit that spot in the camera.
This is called a pinhole camera, and the big downside is that not very much light can get through this little tiny hole. So if you think about what the camera is actually doing, you can start coming up with other ways of achieving the same thing. For example, you could take a tube, and if you looked through it, you sort of see just one point way off in the distance.
If I systematically moved the tube around and kept track of what it saw, I could recreate an image of everything that it saw. This is
I
basically
love the
what I
pictures of
want to
his
do.
wife.
What's really cool is you can make this tube act like different lenses. If I moved it over a really big angle range, I could get a wide angle view. If I moved it over a really small range, I get more of a zoom lens. So where things get really interesting is if you can move this tube around in space and change its angle, you can make it act like some very, very strange optics.
This is the key to seeing around walls, but one step at a time.
Now that I'm thinking about
Just because she's married doesn't mean she's going to be married forever. Although, I don't think I'd stand a chance against this guy. He is such a good engineer.
it, moving a sensor around to collect all the points in an image is gonna be kind of hard because of time. If I was scanning out an image as a series of rows, there's gonna be thousands of these rows. Unless I'm going really fast, it'll take forever.
And if I make a gantry go really fast, it's going to vibrate, which will ruin my image.
And I spent a long time thinking about how I could do this, and I came up with something that I think will work.
So I'm going to put the sensor on an arm that spins. The sensor can move up and down the arm to change where it is in space, and it can also change the angle that it's pointing in. This is a very simple mechanism that'll let us move the sensor around and change where it's pointing.
This is nice because once I get that arm accelerated and going, I'm not gonna have to slow it down. It just is gonna spin real fast till I'm done. So there won't be
This sounds so dangerous. Like, I'm just imagining when it's at the very end of the arm and it has the most angular momentum, and this thing's probably swinging around like a helicopter blade. And then, you know, a screw comes loose and it goes flying and the camera like flies
the
across the room.
accelerations causing vibrations, as long as I have it balanced really well. There's a few other nice things about this design, but it'll be a lot easier to describe once I get it made. So let's make some stuff.
As is my custom, if there's any possible way to make the metal parts on the water jet that's what I'm doing. I have a number of hybrid parts that I 3D printed and then post-machined, which is way faster than machining them from scratch. And despite my efforts to avoid it, I still had to machine some metal parts. Somewhat shockingly, all the hardware went together and pretty much worked.
I think that's the first time that's happened for him in any
Reality
video I've
turned
watched.
out to be a bit more
Like, he only needed to
complicated than
build
my
it
stick
once.
figure drawings, so let me give you a tour of how this thing works. So this entire arm is the part that spins. And on this end is the photo detector. It's on a little cart that can move up and down this rail. And then on the cart we have the photo detector, which is looking sideways at a mirror that we can precisely control the angle of. This lets us control what angle we're looking out at with the camera. I'm using a mirror because it's a very light, easy thing to move, especially when it's on the end of a spinning arm that's going to be experiencing really high G-forces.
You know, that sounds like a really good way to avoid having the man. Because, like, what I was thinking was, like, it would be the, like, lens spinning around at full speed, and the lens is probably going to be, like, sort of heavy. But when so, like, doing just the mirror, right? Just the mirror means you'd have to move less mass, and it's, like, less that's gonna, like, fling off. But when I look at this, now that he explains it, the lens is still, like, on the very end. Why? I feel like he should have put the lens, like, here, in the middle. He should have put the lens, like, in the middle, and then just had the mirror out on the end.
And of course, this is a big, heavy thing on the end of an arm. If we spin it around, it's not going to be balanced, and it's going to vibrate like crazy. So on the other end, we have another cart with a little steel weight that weighs the same as the photo detector. And this moves to the same position as that's moving to. So no matter where we move it, it's always balanced. Another sort of complication with the design is that everything is spinning. If we run wires from something that's sitting still to this, they'll just twist up and break. So the motor drivers, the computer, the microcontroller, they're all spinning too, which makes it really easy just to run wires to whatever I want. And then down here, there's a giant motor that spins everything. And it's not spinning, it's sitting still. And I wanted to control it with my main computer. I didn't want to go wireless, so there's a very special device right here called a slip coupling. It has wires that come out of both ends, and you can spin the wires and they'll never get tangled. And then the last piece is this. This is an encoder. It's a sensor that lets me measure the exact rotation of the arm as it spins. If I don't know exactly where the arm is, the image will not possibly look good. I also really like this wooden post. I spent a while thinking of complicated welded or sheet metal things, but I thought, you know what? This is one of those cases where a chunk of wood is perfect.
Easy,
That's
just a
basically
big
it.
thing of wood.
Before we can start taking pictures,
Just
we
like
need
your
some
mother's
software.
used to.
So I hacked some code together, and here's how it works.
The software starts by asking us what kind of picture we want to take. Wide angle, zoom, something really strange. Then it uses that to calculate how it needs to move the sensor in the mirror to achieve that. Then it controls the motors to spin the arm up to constant speed and precisely moves the camera sensor in the mirror along the path that it calculated. As it does this, the light sensor is measuring how bright whatever it sees is at about 10,000 times per second until all the motors are done moving. I made this little laser tool that screws onto the photo sensor and shines out so we can see where the sensor would be looking. So I'm going to run the camera with this in it so that we can see the shape that it's measuring.
Eh?
It's systematically spiraling from inside out. Wherever the laser is pointing is where the camera would be measuring. The dots being far apart is an artifact of the camera that's filming. The sensor would be getting more like 10,000 dots per revolution.
Which basically gives you a giant graph of how bright whatever it saw was across time. And we have to somehow convert this into an image, which thankfully isn't that bad. Imagine the camera is taking a picture of a wall that was half white, half gray.
Wait, but so if it's like if it's spinning at some speed, is it this caption? Yeah, it's this caption. Do. It must spin at like some, probably, I would think relatively constant speed, right? And the idea is like you take measurements at some certain distance out. If you can take based on your camera, like based on the speed, the shutter speed and the speed, like the RPM of how fast it's spinning, you get like say 360 shots per rotation, right? In the middle, you get like them really tightly packed, but further out, they're like further apart, right? So does that mean he like loses resolution further out? Do you think? Or do you think it like slows down further out? Like I'm actually really curious. But anyway, back to the video. I want to see if he addresses this stuff.
And the camera traces a circle starting at the top. It sees white, which would look bright. But then when it crosses to the gray, it would look dark. Then when it crosses back to the white, it would look bright again. By itself, the graph isn't very useful, but if we keep track of where the camera was pointing, then we know that this measurement corresponds to the top. When it went from light to dark, corresponds to right here, and so on. So if we make a blank image, we can use this information to calculate where any given measurement would fall in this image and set it light or dark depending on what the camera saw.
If the camera had done a full scan instead of a circle, we'd have a picture of the wall.
Alrighty,
Oh, he
so
does
we've
have the
got
higher
data,
resolution.
hardware, electronics, and software. What are the odds this works on the first try?
0%.
Really only one way to find out.
0% chance it works the first time. I feel it. Place your bets.
Looks like it's doing the right thing.
I was kind of slower than I thought it'd be.
Alright, so it technically kind of worked. We got data, it's just not the data that I was hoping for. It is very noisy. I think this is because our sensor isn't getting very much light. So let me show you what I mean. This is the photodetector, which the whole camera is built around. It looks out at some distant point and measures
You were
how bright
hopeful,
it
huh?
is. The heart of our
Things never
sensor is a
work
device
first
called a
time.
photodiode, and it has a little surface on it that measures how much light strikes it. We put the photodiode into a kind of box that we can attach a lens to the front of. If we imagine the photodiode is looking at a point right here, any light from this point would get focused down onto the photodiode, which lets it collect a lot more light than a pinhole camera like I showed earlier. This design does have a problem, which is that the sensitive area of the photodiode is pretty big, which means it'll collect light from where we want it to, but light coming from other spots will also hit the sensitive area, which is no good because we're not measuring a single point, we're measuring a big area, which will just...
The other thing I'm worried about with, especially when he like draws this diagram, is like, it seems like the lens is really focused for a really specific range, right? So does this only really detect like light well at like 10 feet, 20 feet? Does it work at different distances? If it worked the first time, something's wrong? Yeah.
So I have a metal plate in front of the photodiode with a tiny little hole in it. That way, only light coming from the exact spot that we want will be seen by the photodiode.
But the issue we're having is even with the lens, not much light is reaching the photodiode.
So normally if you're not getting enough light with your camera, you hold it very still and you take a long exposure. But I'm whipping the sensor of my camera around at meters per second. If I try to take a long exposure, it's gonna be measuring an arc, not a point. We just have to deal with the fact that we're getting a small amount of light. So let me show you why that's a problem. When light goes into the photodiode, it puts out an electrical current proportional to how much light it's seeing. So more light, more current, less light, less current. And the output from my photodiode looks like this. There's so little light, there's almost no signal. So we have to put it through a special device that amplifies the signal so that a computer can read it. Our signal
His
is so
graphics are
small,
so
we have to boost
good.
it by 10 million times. And because this is real life, our signal isn't perfect, there's noise in it. And that also gets boosted by 10 million. This is our problem.
Here it comes, chat. Here it comes. Low pass filter. I'm calling it here low pass filter. That's probably a super oversimplification, but this is me putting my quarter on the table calling it.
A big part of the problem here is that I tried to make my own transimpedance amplifier. I spent way too long on this. I spent weeks trying to make this work. And ultimately, I realized the thing that I already knew, that some things are just worth spending money on. And this is one of those things for sure. All right, so it's
That's
a new
way
day.
fancier than
We
what
got
I was
ourselves a new
thinking.
amplifier. Let's see what this thing can do. I can't call this picture good, but it's so much better than before.
It's trippy.
It's not just noise.
It's
we can actually see
psychedelic.
stuff. I'm not sure what that stuff is. We had to figure out why it doesn't look like the stuff that we expect it to look like, but this is a really good start. The other big question is, why is the center blank?
The blank center turned into the wildest of goose chases. It really seemed like a low-level software problem, but I could just not find it until I noticed something. You've got to be kidding me. So those
He said it. He said all the hardware went together immediately. Little did he know. Little did he know. The vibration broke the terminals.
those pins would sometimes touch, and they're really not supposed to.
That's a weak mic.
Oh wait,
So those
it
pins
wasn't a break? He didn't break something, he just had things way closer than they should?
would sometimes touch, and they're really not supposed to.
That's a week of my life I'm never gonna get back. I don't know how it didn't just burn everything up.
And after all that, the images aren't any better. They just have the middle. I'm not even sure how long I spent trying to fix all the issues, but it was a long time. I'll spare you the details. It was
It's
basically a
so-
never-ending game of
it's so
Medusa
trippy
whack-a-mole,
looking.
where you fix a problem and two more appear.
Integration hell.
Try number 137.
The thing I've learned over the years is that there's a finite number of issues, and eventually...
Wait, guys.
The thing I've learned over the years is that
Why do you think he calls it sweet potato camp? Is this a joke I'm missing? Is there something about sweet potatoes? Wait, sweet potatoes are yams, right? Is it a yam camp?
finite number of issues, and eventually, it works.
Wait!
Yes! Finally! There's the wall. There's the wall. We took an actual picture of the wall. Who needs drugs when you have engineering? I had no idea you could be this excited about a picture of the wall. That is so good.
Chat, how long do you think it took to get all the samples for every part of this picture? Like, do you think this picture took 10 minutes for the camera to do its spinny?
I guess now that it's working, we should get some pictures that are a little
Less
more
potato
interesting.
cam? I see. 3 days? Honestly, maybe. There's still distortion in the middle. Why are they all distorted in the middle? But they actually look really good.
I'm having a lot of fun taking pictures, but I built this thing to take unusual pictures. So let's see if we can do some of those.
First thing I want to try to do is eliminate perspective.
The way a camera and your eyes see the world is through a sort of expanding cone, sometimes called your field of view. This is why stuff that's further away looks smaller. It takes up less of the total area that your eye can see, and why things look huge when they're right up against your face.
All the photos we've taken with the camera so far have a field of view like this.
But since we have control over where our sensor moves and points, we can make it always point straight out, so it sees a field of view that doesn't expand or contract. Then everything should occupy the same field of view, no matter how far away it is. In other words, there shouldn't be any perspective.
I thought he had.
I have two foam
bought
heads
a
that are the
lens
same
like that
size.
in
On a
one of his
normal
previous
camera,
videos.
the one that's further away looks a lot smaller. These should look the same size to the camera.
Oh my god, is this gonna work? Hey! That's
is
pretty cool.
So awesome. This head could be 100 feet behind the other head, and it would look the exact same size. That's not normal. It's an orthographic projection in real life.
It's just so cool.
Another weird lens we need to try is reverse perspective. The idea behind this is really simple. So all we should have to do is take the expanding field of view that cameras see and reverse it. It's essentially a giant lens with a negative field of view. Things that are close to it will appear small, and things that are far away will appear large. At least in theory. We've got Mr. Crown behind Mr. Wig. If this works, he should look bigger.
What?
Isn't that amazing? Crown Man
It's
is
actually
way
so
behind
cool.
him, but he looms large over Wig Man. I don't know why it's so satisfying, but you have this weird theoretical thing, and then seeing it actually come out in an image is just the best thing ever. I like his little pinched face. The main thing I've wanted to see this whole project is if I can look around an object. So I have to warn you that this one is pretty weird. So if we look at a normal camera from the front, the expanding cone that it sees is coming from one point. I want to take this point and turn it into a ring that's seeing sort of an expanding cone at every point on it. This would basically be a camera with a giant lens that's a ring.
I told you this is gonna be kind of crazy.
If we sliced this imaginary camera in half and looked at it from the side, this is what the field of view would look like. And what's really cool is if you put something in front of the camera, up to a certain size, it can see around it. Which means if I
Chat, do you think this is gonna work? Do you, I think this working, are you guys betting on this working within the first 3 attempts? 3 attempts. Or you think it's not going to work with it? I think I'm like 80% sure he wouldn't have this included in the video if he never got it working. I'm sure he'll get it working eventually. But do you think it's more or less than 3 attempts? I feel like it might be less. But
was hiding
let's see.
behind something, it
And
could
this is
see
going
me.
to be really, really
The big
tricky to
question
see.
is, what is it going to look like? Will it make any sense at all? So let's find out.
Definitely less?
All right, and I have to stand very, very, very still.
It is really hard to stand this still. I should have used a chair.
I'm pretty sure I moved. I guess we'll see.
Whoa! Whoa! It was a one-shot.
This is way better than I was expecting.
Also, it's really interesting when you think about it, because, these, weird earlobe things must be, the corners of the cardboard, right? Because the corners stick out further, radially from the center of the camera.
This is way better than I was expecting. I didn't expect it to be so clear. I kind of look like a Neanderthal, or something really heavy hit me in the dome. I was expecting this to be just totally messed up, where if you squinted at it, you might see a face. This just comes out of the camera looking normal. The thing that's hard to make sense of is this sort of rabbit ear looking thing in front of me. And that's the barrier. So as the camera goes around, it would see around in some spots and not in others. At the bottom, it was always blocked, but it would start to become unblocked and see me from the side. Then it would go up and it would be blocked by the corner again. Then it would come over the top and it would be unblocked and it would repeat. I'm pretty happy with this. This is really cool. The pictures I've been getting out of this camera are really cool, but they're all black and white, which is kind of, I don't know, it's left me unsatisfied. It's the 21st century. We have color.
Is he gonna do
photographs,
color?
right? But the way that it works with the photo detector, it just sees how bright stuff is, black and white. But when a digital camera takes a color photo, there's actually 3 sensors for every pixel in the image that measure the red light, the green light, and the blue light. Turns out that just collecting those 3 colors allows you to recreate a full color image. And the reason this works is due to the specifics of how your eyes see color. I'm not gonna get into those weeds right now, but we should be able to do basically the same thing with this camera. So I made 3 little color filters,
He needs to
red,
give
green,
us
and
some of
blue,
his smartness.
that we can attach onto the camera. So if we take 3 pictures with all 3 filters, we should be able to combine them and get a color image.
Exactly, Prue. A
see if
taser
we
that
can do
shoots
it.
around walls. Oi!
It
Oi!
actually works. You see the images coming in, they look terrible, and you stack them, and it's just like, bam, color photo.
It's so
I think
good!
this is my favorite thing I've done with this camera. I don't know why. It has all these imperfections and flaws. The images don't line up exactly right, but it's all real. I didn't do this in Photoshop. This is the camera making real garbage. It's authentic garbage, and I love it. And then I did a low resolution photo, and I actually like that one more. It's like a pixel art view of my scissor lift. It's just so cool looking.
It looks like it could be something that was like almost AI generated, just
I
because of
hope
like
I
weird
explained this thing
fuzziness.
well enough that you
That-
generally understand it, but I know I glossed over a lot of stuff. Like, how does it take millions of sensor readings and turn that into an image? The basic unsatisfying answer is math and science, which I've spent a lot of time learning. It's what enables me to make stuff
Here's
like
a
this.
sponsor
So
chat.
if you want to learn technical stuff so you can make
Here's the
stuff too, you should check out this video's sponsor.
You want a scissor
Brilliant.
lift?
I like to describe
I
Brilliant
wanna
as a
scissor
tool
your
that's
mom. What,
really
huh?
good at
Yeah?
teaching you technical stuff. It works by taking complex topics and breaking them down into a series of bite-sized lessons. So if you want to learn linear algebra, which is really useful,
Chat, what the fuck? Were they listening to us talk about I did not pre-watch this. I did not pre-watch this.
it's actually the math that I use to convert measurements into pictures. Brilliant has a whole set of lessons on this, which first teach you theory, but then have you solve actual problems, which are also interactive. So you're learning and doing, which is just the best way to learn. Another important part of learning is being consistent. I try to spend at least 30 minutes a day learning something new. It's actually how I've picked up a lot of my skills, and Brilliant is designed for this. The lessons are the right size for you to do.
What do you mean it happens every time, Penboo? Huh? You trying to call me a one-trick pony? I mix it up sometimes.
1 or 2 a day. If you make a habit of doing this, you will be shocked how much you learn. So if you want to expand your technical skill set, you need to check out Brilliant. I've used it a ton, it works great. They literally have thousands of lessons across programming, math, machine learning, all kinds of stuff. And you can try it for 30
He's so
days
cool.
for free. Just go to brilliant.org/stuff made here, or scan the QR code, or click the link in the description.
Wait, but there's
and
still
you'll
3
also get
minutes in the
20%
video.
off an annual premium subscription. And that's it. Thank you, Brilliant, for sponsoring this video, and I hope you go out and learn a bunch of stuff because it's really useful. I know this thing makes worse pictures than a camera that even costs probably $2, but I just cannot help but love it. When I'm using this thing, I feel like I'm making actual art, which I do not feel like with a normal digital camera. I think it's because it is so hard to use, it makes the pictures less cheap. And one thing I haven't done with this yet is try to take a portrait of a person. So I'm gonna get my wife, if she'll let me, we'll see if we can get a portrait seeing around her head. It might be so ugly that she won't let me post it, but we'll have to see. Welcome to my photo studio. What do you think of my camera?
Looks more like a llama or a giraffe.
It does kind of look like a llama. Would you have ever guessed this is a camera?
No,
What would you have guessed that this is?
a llama. It even has nut and bolt eyes.
You probably feel just like the first people who ever saw a camera felt. What the heck is this pile of junk? And then they're amazed. They said, why did I ever doubt you? Oh, I'm so proud of you. You're the best. I think that's what
I
they
would
said to
never
the
doubt
photographer.
you, Shane.
I think they said, looks like a llama.
I'm gonna be trying to take what you might call a non-traditional portrait of you. All I need from you is for you to sit very still. Right there.
How long do you think she has to
Alright,
sit still? It can't.
I know you
10
want to say
minutes?
stuff, but don't. Sit still. You look just like one of the old settlers getting their picture taken.
I don't know if I'm ready.
Here it comes.
It's like I have a beak. I've heard the camera adds 10 pounds.
This one definitely does. It's not that it added 10 pounds, it's that it's seeing you from 5 sides at once. It's your face. It's the top, bottom, sides, unfolded like a map. You would think seeing a woman from all the sides at the same time would be like really beautiful, but
Eh. What?
eyes
He
are,
just
like,
said that about
full
his
of
wife.
despair. Looks like I've seen some stuff.
You know, you kind of look like Thomas the Tank.
Chat, if you're not following Stuff Made Here, you need to follow Stuff Made Here. This guy is the GOAT. This guy is the engineering GOAT. And he's hilarious. Honestly, super hilarious. Ugh. Wife made here also. Wife made here also. Yeah. This is why I love science. People do just such wacky shit. Wacky shit. They say like the humanities and the arts people are artsy, but I think this is pretty artsy and creative and whatever you want to call it. maybe I'm just like a loser. But anyway, it's 9 p.m. I still have to do homework due tomorrow. So I think I'm gonna call it. Thanks for watching, guys. I hope you had a good time. I know I did. I know it's been a long time. It's been a while since I streamed, and I'm sorry for that. Here. But I hope you had a good, fun time watching. I had a fun time watching this video and yapping, and I hope you guys had a good time too with me. So thanks. I think maybe I'm gonna try and just stream like whenever. I think I would like to try and make a habit of just streaming when I can, because I feel like when I've had this sort of like schedule idea in my head, the times when I don't really feel like streaming during the time slot happen, and then other times I'm like, I could probably stream right now, but that's not really when my schedule is, and then I end up not streaming. I think it's probably better for me to just, stream whenever, and then hopefully end up with more streams. So maybe we'll see more streams happening more often. But anyway, thanks for watching. Thanks for hanging out. Have a good night. And I'll see you whenever. Maybe tomorrow. Probably this weekend at least. Tomorrow, if I finish my homework early, maybe too. But yeah, have a good night. Bye.